Hello, this is part 3 of the graphical solution tutorial. This problem was not actually on the tutorial, but I decided to add it. I went ahead and graphed each of the lines representing the constraints, and now we're left to determine which way they're facing. Which area are they limiting? Let's start with the constraint 1, this one. So to test whether this constraint is facing this way or this way, we're going to use this point we call T. Now we usually test with point 0, 0, but since this constraint is, this line is going through the point 0, 0, I decided to use a different point. So point T has the coordinates of 1, 2. To test whether or not it is contained in the area limited by this constraint, we just plug in its coordinates in the constraint and see whether or not it's satisfied. So this is the constraint. It's 3x minus y greater than or equal to 0. So the coordinates are 1, 2. So it's 3 times 1 minus 2. 3 minus 2 is 1. 1 is in fact greater than or equal to 0, and hence T is contained in the area limited by this constraint. So this constraint is going to be facing this way. Okay, now for constraint 2, we use the same point, T. We plug it in the constraint, x plus y greater than or equal to 4. So 1 plus 2 greater than or equal to 4. But 1 plus 2 is actually 3, which is not greater than or equal to 4. Hence, the constraint is not satisfied. Hence, T does not belong to the area limited by this constraint. Hence, this constraint faces away from point T. It's facing this way. So this one is facing this way, and this one is facing this way. Okay, so for the third constraint, which is y equal to 1, greater than or equal to 1, we plug in the same point. So y equal to 2. 2 is greater than or equal to 1. So this constraint is satisfied by this point. Hence, it's going to be facing this way. So I know you're thinking that this is definitely an unbounded solution, since this is the area, but we really need to graph the objective function first, so we can say for sure this is an unbounded solution. Please do not don't jump to conclusions very soon. I went ahead and drew a couple of z lines, z equal to 0 and z equal to 6, and I concluded that the direction of maximization is this way. Hence, if I keep drawing the z line, parallel lines to these two lines, I can conclude that as x and y increase, the objective function keeps increasing arbitrarily and nothing would stop it. And hence, now I can say that this LP is unbounded. Let me know if something is unclear, and thank you for listening.